All right, here we go, algebra, with our last section of chapter 4. This is 4.7, so go ahead and label that on your notes. We're going to graph linear functions. So your goal is to be able to graph and compare linear functions. So let's get into our warm-up because this is a skill we all need to review for our chapter 4 test. Tell whether the ordered pair is a solution of the function. So here's my ordered pair. So to test if it's a solution, I'm simply going to substitute my x and y value into the equation. So my x value is 3. So I have 2 times 3 plus 3 times negative 2 equals 2. So this is going to make a true statement if this point is a solution. 2 times 3 is 6. A positive 3 times a negative 2 is a negative 6. And now I can simplify. 0 on the left side, 2 on the right side. That is not a true statement. So no, 3, negative 2 is not a solution to this equation. Let's check number 2. Notice this time I have a negative x value or a negative x coordinate, and I also have a negative x. So the only thing I'm substituting in for is just the x. So I need to put my negative and then substitute my x value, which is negative 5. So this is truly a negative 5. So make sure you keep track of that. And then I substitute my y value, which is a positive 2. So now as I simplify, a negative times a negative makes a positive. And a negative 4 times a positive 2 makes a negative 8. And as I simplify, 5 minus 8 is negative 3. So this is a true statement. Negative 3 equals negative 3. So that means that this is a solution of the equation. All right, number 3, the weight of a person on Mars is given by the function y equals 0.371x, where x is the weight of a person on Earth. So if a person weighs 130 pounds on Earth, I can substitute this in for x because x is my weight on Earth. And we're going to use that to find the weight of a person on Mars. So my equation, y equals 0.31x, I'm substituting in 130 for x. Now to solve, I simply multiply, and I get 48.23 pounds. Would be the weight of the person on Mars if they weigh 130 on Earth. All right, number 4, I want you to put your thinking to this and come up with some ideas. So we're trying to define parent function. So far, we've only talked about functions, and we've been looking a lot at linear equations. So think about what you know about the word parent and what you know about functions and what that could possibly mean. So I will give you a little background while you're thinking. We have what we call families of functions, and a family of functions is a group, and these functions all have similar characteristics. So we've been looking at functions kind of in that y equals mx plus b form, and those would all belong to our family of linear functions. So think about how you might be able to put words to what a parent function might be. I know that this is a brand new term, so I just want you to think about that for a little bit as we work through this lesson. All right, on to our first example. For example 1, we're going to evaluate the function when x equals negative 2, 0, and 3. So that means one at a time I'm going to substitute these values of x into my function. And each time I'm going to solve once I've substituted in. So here's something to know about functions. When we write a function, we use the letter f, and then in the parentheses, we use the variable that it is a function of. So we would read this part right here, we read that as f of x. So that's literally how we would read that. So this is my function, f of x equals 12x plus 1, and I'm going to find the value of the function when x equals -2. So here's how I write that. I would say f of -2, and then I'm going to substitute -2 into my equation for x. So 12 times -2 is -24. -24 plus 1 is -23. So I would say f of -2 equals -23. And now I'm going to do the same thing for my next value of x. So I'll say f of 0, and now I substitute 0 into my function. So 12 times 0 plus 1. 12 times 0 is 0. 0 plus 1 is 1. So I would say f of 0 equals 1. And finally, I'm going to substitute 3 into my function. So I would say f of 3, then I'm going to substitute in here. So I'm going to have 12 times 3, sorry, I'm trying to squeeze this in, plus 1. So f of 3 equals 12 times 3, which is 36, plus 1 is 37. So now I have evaluated, or I found the value of my function for each of those given x values. So that's how we read this function notation, and that's how we would give our answers. So let's check out part B. We're going to do the same thing. This time our function is h of x equals 1/2 x minus 6. So I need to find h of -2. So I will substitute -2 into my equation and try to fit all of this in here. So 1/2 times -2, I have a positive times a negative. That makes my answer negative. And 2 times 1/2 is 1 whole. -1 minus 6 is -7. So I would say h of -2 equals -7. Now if I want to find h of 0, then I put 0 in for x, and I find that 1/2 times 0 is 0. 0 minus 6 is -6. And last, let's find h of 3. So I substitute 3 into my equation. And I apologize, I'm running out of room. You won't be able to see this part. But I'm doing 1/2 times 3 minus 6. So in this case, I'll try to scoot it over. We're just going to be real short on room. Let me see if I can write this for you and then erase it. So 3 times 1/2 is 3/2, or 1/2. So I have 1/2 minus 6. So I'm at positive 1, and I'm going to go left 6. Or I'm at positive 1/2, and I'm going to go left 6. And I get -4.5. So let me go ahead and erase this so I've got room to show you the next set. But I think you've got the idea. Boy. See if I can get my eraser to cooperate. Okay, sorry about that. All right, let's get some clean space here. So let's check out example number 2. So we've practiced finding the value. Now we are going to find an x value so that the function has an overall given value that we're looking for. Try to get this back to where it was. Okay. So on part A, I have g of x equals -x plus 5. And I'm trying to find the value of x so that this whole function has a value of 2. So what I'm going to do is I'm going to substitute 2 for g of x. Not for x, but for this whole thing, g of x. So I replace g of x with 2, and now I'm going to solve the equation. So I want to get my variables on this, or my constants on the same side. So I subtract 5 from both sides. And now I want to turn my x positive, so I'm going to divide both sides by -1 so that x equals 3. So what that means is that f of 3 equals 2. So 3 is the value I substitute into this function for x so that I get an overall value of 2. Let's try the same thing on part B. This time our function is n of x equals -2x minus 21. And I want to find the value of x that makes this whole function have a value of -6. So I'm going to substitute -6 for n of x. So -6 equals -2x minus 21. Now I have a two-step equation that I will solve for x. So I'm going to start by adding 21 to both sides. -6 plus 21 is 15. And now to get x by itself, I divide both sides by -2. Oops. And 15 halves, it's going to be negative because I have a positive divided by a negative. And if I want to, I could go ahead and make it a mixed number or a decimal. So 15 halves would be the same as 7.5. So x equals -7.5. So I would say f of -7.5 equals -6. All right, let's check out our next section here. For example 3, we are going to compare the function, or we're going to graph the function and compare it with the parent function f of x equals x. So here you're hearing about that parent function again. So our parent function, it's kind of the most basic function in the family. It's the one that all the other functions in this linear function family come from, which is why we call it a parent function. All the other linear functions are derived from this parent function. So it's really the simplest one. So this is my parent, this is what we call my parent function right here. Get my pen tool going here again. Okay, so my parent function is f of x equals x. So what that means is that any number I substitute into the equation for x, that is essentially also going to be my y value. So to show this, let's make a table, kind of an xy table, except now you'll notice that we have the function notation taking the place of y. So in my table, I'm going to make an x column and an f of x column. So instead of xy, I'm going to have x and f of x. So I get to choose my x values. So I'm just going to go ahead and do, let's give ourselves enough room here, -2, -1, 0, 1, and 2. I notice on the way they've set up these graphs that I'll have room on both of these graphs for my x values to go from -2 up to +2. So let's substitute in to this parent function then. And my parent function, again, since you can't see it now, says f of x equals x. So if I want to find f of -2, then I substitute -2 into my equation for x. So f of -2 equals -2. If I want to find f of -1, then I substitute -1 in for x. So f of -1 equals -1. Hopefully you are detecting a pattern here. F of 0, I'm going to substitute 0 in for x. So I think we can safely fill in the remainder of this